Thermometer used to measure the temperature of 66 gram water give a reading of 32.4 degrees C. If the heat capacity of the thermometer is 19 joule per Kelvin and its reading is 17.8 degrees C before measurement, find the actual temperature of the water Tx. This diagram shows the thermometer used to measure the temperatures of 66 grams of water. The heat transfer from water to the mercury in the thermometer and makes this mercury expand. So the mercury columns will rise, will become longer. When the water and the thermometer achieve the thermal equilibrium, then the net heat transfer from the water to the mercury will become zero. Then the length of these mercury columns will become fixed. Then from the length of these mercury columns, then we can know from the calibrated scales what is the readings of the temperature of the water. The thermometer putting in the air shows the reading at 17.8 degrees C. This is the readings of the temperature before the thermometer is used to measure the temperature of the water. But when this thermometer is put into the water to measure the temperature of the water, the reading shows 32.4 degrees C. This is a T2. But this 32.4 degrees C is not the actual temperature of the water, because some of the heat transfer from the water is absorbed by the bodies of the thermometer itself. So that means it is not 100% of the heat transfer from the water is absorbed by the mercury. If all the heat that transfer from the water to the mercury and no any heat is transferred to the bodies of the mercury, then the actual length of this mercury should be higher, which is shown in this diagram. Therefore, the actual temperature should be Tx. Since we know the initial temperature of the thermometer before it is putting into the water, and the final temperature after it putting into water and achieve the thermal equilibrium with the water, so that means we can calculate what is the heat absorbed by this body of the thermometer. We have this heat capacity of the thermometer is 19 joule per Kelvin. So if we use this 19 joule per Kelvin, which is a C, multiply with the delta T, or T2 minus T1, we can find out what is the heat absorbed by the bodies of the thermometer. So this part of heat is not used to expand the length of the mercury. It is not absorbed by the length of by the mercury. It is absorbed by the thermometer itself. The Qt amount of heat absorbed by the thermometer is come from the water. So we can find this QW, which is MWCW Tx minus T. This Tx minus T2. Tx minus T2. This expression is the heat from the water that is absorbed by the thermometer itself. So if this heat is not is all absorbed by the thermometer, then supposedly the actual readings that reflects the temperature of the water should be Tx. That's why we use Tx minus the T2. This part of the length of the mercury should be produced. If this part Qt of the heat is not absorbed by the thermometer but is used to expand the mercury columns. Since the Qt and the Qws are the same, then we can equate them, put the equality sign between them. So we have at the left hand side MWCW Tx minus T2, and at the right hand side the capital C times T2 minus T1. Since we want to find the Tx, the actual temperature of the water, after the mercury or the thermometer is in thermal equilibrium with the water, we want to find the Tx. So this Tx, we can change it as a subject to get these expressions. Okay, and then we can substitute a value for all these quantities, where the C is a specific heat capacity of the thermometer, 19 joule per Kelvin. T2 is 32.4 degrees C. T1 is 17.8 degrees C divided by MW. MW is the mass of the water, which is 66 grams. In kg, it is 0.066. The specific heat capacity of water is 4,200. And then plus the T2. T2 is 32.4. So we'll get the answer for the Tx is 33.4 degrees C. So this is the actual temperatures of the water. If part of the heat is absorbed by the thermometer, the readings that we obtain is 32.4. But if we assumes that there is no heat absorbed by the thermometer and all the heat from the water is absorbed by this mercury, then the reading is 32.4 degrees C.